In this lesson, we will be solving equations. Our guiding questions: what is actually happening when you solve equations? And what are the three possible solutions when you solve an equation in the first degree? You should answer these questions when you finish the video. An equation is a statement that two expressions are equal. In this lesson, you'll use equations to model and solve problems. We use our properties of equality and the inverse operations to help us solve equations. Our properties of equality are just things you need to be aware of. The reflexive property just says that A equals A. Example, 5 equals 5. The symmetric property just says that the order doesn't matter. A equals B is the same thing as B equals A. The transitive property says if A equals B and B also equals C, then we can say that A equals C. The substitution property says if A equals B, then you can replace either A or B with the other. Our properties of equality continued. These properties we went over back in Algebra 1. Addition property just states if I add one number to one side, I have to add the same to the other. And the same with the operations of subtraction, multiplication, and division. What I do to one side, I do to the other. To find the solutions of an equation, you must isolate the variable on one side of the equation. And you can do this by using inverse operations, which are operations that undo each other. Addition and subtraction are inverse operations, as are multiplication and division. Now we'll look at a couple of examples. X plus 4 equals negative 12. I want to isolate the x, so I'm going to subtract the 4 from both sides, and I get x equals negative 16. Remember to check by substituting the value for x back into the equation to see if it works. Remember to check. Example 2, I need to get rid of my parentheses first. So on this side I have negative 27 plus 6y equals 3y minus 9. I need to get my y terms on the same side, so I'm going to subtract negative 3y from both sides, and I get negative 27 plus 3y equals negative 9. And I'm going to add 27 to both sides. Then I get 3y equals 18. Divide by 3, and I get y equals 6. Again, remember to check. Now we'll look at example 3. I have like terms on the left side and on the right side of the equation, so I'm going to combine those first. I have my 11 minus 7, which would be 4 plus 3x. And on this side, I have my 6x minus 3x, which would be 3x plus 5. If I look at this equation, if I subtract 3x from both sides, that zeroes out both of my variables on both sides and leaves me with the statement 4 equals 5. 4 definitely does not equal 5, which means that statement is false, which means this equation would have no solution. There is no value of the variable that will make that equation true. If I look at problem number 4, again, if I combine my like terms, 6x minus 2x is 4x. So I have 4x plus 5. And then combine my like terms on the right side, and I have 4x plus 5. Again, if I subtract my 4x from both sides, my variable terms zero out, but this time I am left with 5 does equal 5, which is a true statement, which means my answer would be all real numbers. Any number would make that equation work. So therefore, I have 3 possibilities when I solve an equation. The first possibility, I get one solution, such as x equal 4. Or I get no solution. Or I get all real numbers. So those are the 3 possibilities. Looking at this next problem, I'm going to be applying it to a real world situation. In this picture, it says flower carpets incorporate hundreds of thousands of brightly colored flowers as well as grass, tree bark, and sometimes fountains to form intricate designs and motifs. The flower carpet shown here in Brussels, Belgium has a perimeter of 200 meters. Okay, so first I'm going to look at what I know. Okay, I know that my perimeter equals 200. I know that my length is x and my width is 3x. So in order to find my length and my width, I need to find the value of x. To do that, I'm going to use my formula for perimeter. My perimeter formula says perimeter equals 2 times length plus 2 times width. So I can substitute in place of my L, I can put 2x, and in place of my W, I can put 3x. And then I also know that my perimeter is 200, so I can make that substitution. Then I just need to solve the equation. 200 equals 2x plus 6x, so 200 equals 8x. Divide by 8, and I get 200 divided by 8, so x equals 25. So now I can substitute my length is 25 and my width is 3 times 25, which is 75. Literal equations are special types of equations that have at least 2 different variables in them. You solve them just like regular equations. You isolate whichever variable it wants you to solve for. So if we look at this example in problem 5, I have the equation for Celsius. Celsius equals 5/9 times the quantity of Fahrenheit minus 32. That shows the relationship between Fahrenheit degrees and Celsius. But they want me to solve it in terms of F. So they want me to get this F here by itself. So to do that, first I'm going to move my fraction by multiplying each side by 9/5. Then I'm going to add the 32 to both sides. And then I have Fahrenheit equals 9/5 C plus 32. So I solve the equation in terms of F. So now, in terms of C. I would like you to do Got It Problem 5.